Okay, these notes are to help you understand how to do trends. So if you remember, we looked at these different diagrams you see on the screen. First one we looked at was one of the ones we talked about was atomic radius versus ionic radius. We know that the trend for atomic radius and ionic radius are as follows. It increases from right to left across a period and from top to bottom down a group. So right to left across a period and from top to bottom down a group. For ionization energy and electronegativities, it increases from bottom to top up a group and left to right across a period. Bottom to top for a group, left to right for a period. And then we did something to help us distinguish between parent atoms. Strontium and chlorine are parent atoms. Their ions are strontium 2 plus, and the ion of the parent atom of chlorine is chlorine 1 minus. And we use this little silly phrase, small cats eat large onions. Small cats means cations. That's what CAT stands for in our little trick here. And large onions stands for negatives or anions. So here, if I looked at these two, and we're going to compare the parent atom of strontium to its ion, small cats tells me that this is smaller. So strontium 2 plus is smaller than its parent atom. Large onions tells me that this one is larger than its parent atom. And if we try it over here again, small cats, that means this is smaller. So Mn7 plus, a cation, is smaller than the parent atom of Mn. Large onions means sulfur 2 minus is larger as an anion or as an ion than it is its parent. Okay, so first question is a radii versus a radii. So when you have a radii versus a radii, you want to focus both on the word in the middle of the sentence, basically larger. So we're going to look at, in this case, fluorine and its ion is a 1 minus, and sodium is the parent atom, parent atom, and it forms a +1 ion. Now, to find these charges, you're going to look on the back side of your periodic table's lower portion. And if you just search left and right on there, you'll see each of the atoms' ions. So you'll see what their ions look like for each atom that we will be using. So I want to know larger. So because I'm focusing on larger, I know small cats. So then I'm looking at the atom, parent atom, and its cation, and I know small cats. So then if I know this is smaller and I'm looking at larger, then I'm going to circle Na because it's the larger of the two. And then the large onion part here, I'm going to see which is larger. Well, the large onion means that the anion is larger, so I'm going to circle this. So now I've circled and focused on the word larger in my little phrase there. Then I'm going to go back and ask what it's talking about. It's asking about the atom's radii is larger. So as I look at this one and this one, which one's atom is larger, and that would be sodium. So on the sheet, you would put capital N, lowercase a. This time we have smallest first ionization energy. We know the trend increases this way and this way, and so that means it's increasing in the up direction. So the smallest will be SR. Smallest atomic radius. We know atomic radius increases right to left and from top to bottom, and it wants to know the smallest. So if I'm going to do this direction, we see RU is the smallest. Most electronegative, there's a spelling there that should say most electronegative or largest electronegativity. Most electronegative is going to be, we know the trend increases up a group and left to right across a period. So we want to know the most electronegative, so that would be AS. Here we have a radii versus radii, so we focus on that word larger or smaller. We see larger, so now we're going to apply small cats. That means barium is larger than its cation. Large onions, we know phosphorus is larger. And then we're going to go back into the sentence again and focus on what it's asking is larger. It wants to know which one has the ion is larger, and then we put phosphorus on there because phosphorus ion is larger than its atom. Here we have largest atomic radius again. This time we're thinking about the trend. We know the trend does this. When we know, pardon me, it increases from right to left and from top to bottom. And so we know it's increasing that way. So the largest would be BH. If we go to the next example, most electronegative. Electronegativity increases from bottom to top on a family, left to right in a period. The most electronegative then would be TS. Here again we have radii, so we're looking at smaller this time. Small cats eat large onions. So because small cats, cations are smaller than their atom, anions are larger. So if anions are larger, that means the negative is larger than I, and we're focusing on the word small, so we'd circle the I. And now we want to know atoms. Which one's atom is smaller? And that would be iodine. Largest first ionization energy. We know ionization energy increases this way and this way. Largest is going to be, in this case, Zn. Excuse me. Largest first ionization energy. Again, we know that it increases bottom to top and left to right across a period. So we're looking at this direction across the period here, and we know Br is going to be the largest. Smallest atomic radius. We know atomic radius increases right to left and top to bottom. Smallest is going to be Mg. Smallest first ionization energy. Ionization energy we know increases up a family or period and left to right across a, up, I said period, up a family or group and left to right across a period. Drew the right thing, said the wrong thing. Okay, so we are looking at this here, and so the smallest first ionization energy would be Nb. And we're looking at radii again versus radii. We're going to focus on the word smaller. We know small cats, so that means the cation is smaller. Large onions, the atom is smaller. And it's asking for which one has an ion that is smaller, so you're going to put Cr as your choice. Least electronegativity, or least electronegative, we know it increases this way and this way. So the least electronegative would be Te, as it's lower on the group or family. Smallest atomic radius, we're going to go from right to left and from top to bottom. So smallest would be Ga. And that ends and concludes our notes. Feel free to reach out for help. You can come in during Tiger Time or stay after school if you need some additional help, or feel free to listen to the video again. Thank you and have a great day.